Completing the square to solve. Now when we say to solve, we mean to get the x-intercepts, the roots, or the zeros. All means the same thing. And what that means is where the parabola is hitting the x-axis. So that's what we're solving for here. Our first step in completing the square, when you have an a term that's not exactly equal to 1, you're going to need to divide everything by that number. Let's first get it into standard form. So subtract the 4 over to the other side so that it's 3x squared minus 2x. And then negative 2 minus 4 is going to give us a negative 6. Now, before we can do anything else, now that it's in standard form, we need to get rid of that a term to make it a 1. So we divide everything by 3, leaving us with x squared minus 2/3 x minus 2 equals 0. Now we can complete the square normally. So now we add the c term over to the other side. We rewrite it as x squared minus 2/3 x plus blank equals 2 plus blank. And in that blank goes half of this b term squared. Well, half of means multiply, negative 2/3 is going to give me a negative 2/6, which reduces down to negative 1/3. So in the parentheses, we write negative 1/3 squared. Make sure you have that negative sign because the b term was negative. Now on the left-hand side, we just rewrite it by taking one of the x's and then negative 1/3 and squaring it. Now everybody always asks what happened to the middle term. Well, we're just rewriting this because this is a perfect square trinomial. If I were to use FOIL on this and do x minus 1/3 times x minus 1/3, it would bring me back to get the negative 2/3 x that we have here in the middle. So it's not disappearing, we're just writing it differently, but for our purposes, you could assume that it's just disappearing, it's gone. Now on the right-hand side, negative 1/3 squared means negative 1/3 times negative 1/3, which is positive 1/9, and 2 plus 1/9 is going to give us 19 over 9. Now we want to solve for x, so we take the square root of both sides. This cancels and now just leaves me with x minus 1/3. It's always going to be plus or minus the square root. Now looking at the top, you cannot take the square root of that, nor can you simplify it by breaking it into a perfect square and a non-perfect square. So we're going to leave that as radical 19, but we can take the square root of the bottom. And since we're taking the square root of the whole thing, that's the same thing as saying the square root of the top over the square root of the bottom. So we're going to rewrite this as the square root of 19 over 3, which is no longer under the square root. When we finally add the 1/3 to the other side, we're going to add it in front of the plus or minus, just to make things a little bit easier. So we get x equals 1/3 plus or minus radical 19 over 3, which is the same thing as saying 1 plus or minus radical 19 all over 3. Now this means that there are two roots. So there are two roots within here. If it does not ask you to round, you can leave your answer as x equals 1 plus or minus radical 19 over 3. But if it tells you to round, then you're going to solve for when x is 1 plus radical 19 over 3 and round to whatever they tell you to round to. And you're going to solve for when x is 1 minus radical 19 over 3. And again, round whatever they ask you to round to. Completing the square to get it into vertex form and then find the vertex. Well, again, we can't have an a term that's not equal to 1. But before we start anything, we're going to subtract the c term over to the other side so that it's now f of x minus 5 plus blank equals. The 5 canceled out, And now from these two terms, we need to factor out just the coefficient, just because we want the a to be in front. And that's going to leave us with an x squared minus 2x, and we have a plus blank inside the parentheses on this side. Now what goes in the blank is half of the b term, which is negative 2 squared. So that's a negative 1 squared and a negative 1 squared. But since this blank is being multiplied by 2, this blank also needs to be multiplied by that 2. Now on the right-hand side, we're going to rewrite it as 2, but now you take 1x and the minus 1 and you square it. And on the left-hand side, it stays f of x, but we're going to evaluate. So negative 1 squared is positive 1, plus 2 is positive 2, and negative 5 plus 2 is going to give me a negative 3. Finally, we want to get the f of x, or the y, however they write it is how you should write your answer, by itself by adding the 3 over to the other side. So we're left with f of x equals 2 times x minus 1 squared plus 3. This is the answer in vertex form. Now, if it asks you what are the coordinates of the vertex, well, the formula for vertex form is f of x, or y, equals a times x minus h squared plus k, where h comma k is telling us the coordinates of the vertex, and x equals h is giving us the equation of the axis of symmetry, which is the vertical line that basically cuts the parabola perfectly in half. Now, when it matches the formula, that means it's positive. When it's different than the formula, that would mean it was negative. In this case, the h sign matches, so the vertex is going to be a positive 1, and the k sign matches, so the vertex is going to be a positive 3. So this is the coordinates of the vertex. Now, by looking at the 2, you can see that it's a positive a value, which means that the parabola is opening upwards, which means that the vertex is a minimum value. And the axis of symmetry is just going to be x equals the x coordinate of the vertex. So just to sum it up, this is a formula that must be memorized. The y is either y or it can be f of x. So if they're talking about a function, make sure you write it the way that they're asking you to write it. And if it doesn't match the vertex formula, then that means if the signs are different, it's going to be a negative value. So just looking at a few quick examples. If we look at our first example, it's different than the formula, which means it's a negative 2. It's the same as the formula, so it's a positive 1. The a value here is positive, which means the parabola is opening upwards, which means this vertex is a minimum. The axis of symmetry would just be x equals whatever the x coordinate is of the vertex. In our next example, we can see that even if it started with a negative 1, that needs to be factored out. So just to make sure, just to clarify that you understand, if I had y equals negative x squared plus 3x plus 2, I cannot yet complete the square. When I subtract the 2 over, I would need then to factor out the negative 1. So it would be y minus 2, but then I'd have to take out the negative 1, and I'd be left with x squared minus 3x, and then my plus blank. Okay, so you can't have even a negative a value. But moving on to our next example. So the sign is the same as the formula. It's a -4, so that means it's a positive. The sign is different than the k value, so that means it's a negative. This parabola has a negative a value, which means it's opening downwards because that's a reflection over the x-axis. So that means that this is our maximum for the parabola, and our axis of symmetry would be x equals 4. In the example here, you can see that the -2, it matches the formula, so it's a +2, matches the formula, so it's a +1. A is -2, which means the parabola is opening downwards, so this is my maximum. And the equation for the axis of symmetry would be x equals that +2. In my final example, having this 1 here is optional, but it is a positive a value. Even if the 1 weren't there, it would mean that there's a +1 there. So this is going to be a minimum. The sign is different than the h up here, so that means it's a -2. The sign is different than the k, so that means it's going to be a -4. My axis of symmetry would be x equals -2. So basically the trickiest part about telling me the vertex from this is the h part. Because in the formula it says x minus h. It's supposed to be minus. So anything other than a minus would then mean it had to be a negative x value for the vertex. The reason for that is that this must have been x minus a -2. X minus -2, when you do keep, change, becomes x plus 2. So it changed the formula only because the 2 was negative. But the shortcut of remembering it is just to say, if when you get it into vertex form, it's different signs than the ones they give you, that means it must have been a negative value. And worst case scenario, if you do all of this work to get it into vertex form by completing the square, you could always just go to the calculator, type this into y1, you press zoom 6 to graph it, make sure it fits in the window, second calc, and you want to find the vertex, so maximum or minimum, and then that will tell you the coordinates if you're unsure of whether it's positive or negative. Now, in retrospect, if it also doesn't say get into vertex form by completing the square, you could realistically, like in the past sections, plug whatever the function was or the equation was into y1 in your calculator, find the vertex, and just plug it into this formula, assuming that you know how to find the a term as well.